The Death Star. This iconic symbol of overwhelming power, a weapon capable of destroying entire planets, captures the imagination. But could such a feat of engineering ever be achieved in reality? The challenges are so vast, so daunting, that they push the very boundaries of science and human ingenuity. First, consider the sheer scale. The Death Star, estimated to be over 100 kilometers in diameter, dwarfs any structure ever conceived by humanity. Its construction would require a quantity of raw materials exceeding the total amount of steel ever produced on Earth. And then there's the technology. The Death Star's planet-destroying superlaser demands an energy source far beyond our current capabilities. Even if we could harness the power of a star, focusing and directing such energy remains in the realm of science fiction. The Death Star, for now, remains a testament to the boundless possibilities of imagination. Yet by examining the challenges it presents, we can glimpse both the limitations and the exciting potential of future technology. And let's not forget the cost. Estimates suggest that building the Death Star would require an astronomical budget, potentially reaching into the quintillions of dollars. Constructing a Death Star would require an astronomical amount of raw materials, far exceeding Earth's reserves. Steel, a key component in our current construction methods, would be woefully inadequate for such a massive structure in space. We would need to look beyond our planet, to the vast resources scattered throughout our solar system. Asteroids, rich in iron, nickel, and other valuable metals, present a potential source. Mining these celestial bodies, however, would necessitate advancements in robotics, resource extraction, and space-based transportation systems. Even if we could harvest resources from asteroids, the sheer quantity needed for a Death Star is staggering. Estimates suggest that over a quadrillion tons of material would be required. It's estimated that we would need to capture and process millions of tons of material, a logistical challenge that dwarfs even our most ambitious space programs. The quest for materials alone presents a monumental hurdle in the path of building a Death Star. Building on Earth is challenging enough, but constructing a Death Star poses a whole new set of obstacles. The environment of space is unforgiving. Vacuum, extreme temperatures, and cosmic radiation all threaten the integrity of any structure and the safety of any workers. Traditional construction methods are useless in space. We would need self-assembling structures, perhaps utilizing nanotechnology or advanced robotics, to piece together the Death Star's massive hull. Such technology is currently in its infancy, with many breakthroughs needed before it could be applied on such a grand scale. Then there's the issue of gravity. Assembling a structure of the Death Star's size in orbit, without it collapsing under its own weight, would require overcoming immense gravitational forces. Artificial gravity generation, a technology currently confined to science fiction, might be the only solution. Estimates suggest that constructing the Death Star would require a workforce of over 1 million skilled workers, including engineers, scientists, and laborers, all working in the harsh conditions of space. Next, logistics and labor. The construction of the Death Star would be the single largest coordinated effort in human history. Millions, if not billions, of individuals would be needed across countless disciplines. Engineers, miners, programmers, and countless other specialists would be required to design, build, and operate this complex machine. The logistics of managing such a workforce are staggering. Supplying food, water, and other necessities to a workforce of that scale in space would require supply chains far exceeding anything we have on Earth. And then there's the human cost. Working in the hazardous environment of space would expose workers to significant risk. Ensuring their safety and well-being would be paramount, requiring strict protocols and advanced life support systems. To put it into perspective, the logistics and labor involved would be equivalent to managing the entire population of a large country, with over 1 billion people working in unison. Time and treasure, the price of power. The construction of a Death Star would be an undertaking of unimaginable cost and duration. Estimates for such a project, even with optimistic assumptions about technological advancements, reach into the quadrillions of dollars, dwarfing the entire global GDP many times over. The time frame for such a project is equally daunting. Even with breakthroughs in automation and construction techniques, assembling a structure of such scale in space would likely take decades, if not centuries, to complete. The economic and temporal resources required to build a Death Star highlight the immense commitment needed for such an endeavor. it would demand a sustained, multi-generational effort, with resources diverted from countless other areas of human development. Additionally, the ongoing maintenance costs would be astronomical, potentially reaching hundreds of billions of dollars annually, further emphasizing the staggering price of power. Dream or nightmare, can it be done? The construction of a Death Star, at least with our current understanding of science and technology, remains firmly in the realm of fiction. The challenges, from resource acquisition to space-based construction, are simply too vast to overcome with our present capabilities. For instance, estimates suggest that building a Death Star would require approximately 1.08 x 10 circumflex 15 tons of steel, which is more than the total amount of steel ever produced on Earth. However, the Death Star serves as a powerful thought experiment. It forces us to confront the limitations of our current technology while pushing the boundaries of what we might achieve in the future. Perhaps one day, with advancements in areas like fusion power, nanotechnology, and space travel, such a feat of engineering might become possible. But even if we could build a Death Star, the question remains, should we? The ethical implications of wielding such power are profound and demand careful consideration. The Death Star ultimately is a reminder of both the incredible potential and the grave responsibility that comes with scientific progress.